Good evening, ma'am. I am Manish Sharma from CSC. Today, my topic for CA2 is Universal Logic Gates. We move on. Introduction to Universal Logic Gates. Universal Logic Gates are fundamental building blocks in digital circuits. They can be combined to create any logical function without the need for other types of gates. The two most common universal gates are the NAND gate and the NOR gate. Both NAND gate and NOR gates are called universal because you can build any other gate AND or NOT, XOR and XNOR by combining multiple NAND or NOR gates. You can see what are logic gates. Logic gates are electronic devices that perform a basic logical function on one or more binary inputs. They produce a single binary output based on the logical operation applied. Common types of logic gates include AND, OR, NOT, NAND, NOR, XNOR, and XOR. Logic gates are the basic building blocks of digital circuits. They perform logical operations on one or more binary inputs to produce a single binary output. You can move for characteristics of universal logic. Universal logic gates can be used to construct any digital circuit. They simplify circuit design by reducing the variety of components needed. The versatility of universal logic gates allows for easier troubleshooting and modification. Flexibility. Since NAND and NOR gates can form any digital logic circuit, they are highly flexible in both combinational and sequential logic design. And move for NAND gate. The NAND gate is a combination of a AND gate followed by a NOT gate. It outputs a low signal only when all inputs are high. NAND gates can be used to create any other type of logic gate, making them universal. A NAND gate, NOT AND gate, is a fundamental digital logic gate that outputs false or zero only if all of its inputs are true or 1. In all other cases, it outputs true or 1. You can move for NOR gate. The NOR gate is a combinational of an OR gate followed by a NOT gate. It inputs a high signal only when all inputs are low. Like the NAND gate, NOR gates can also be used to create any other logic gates. We move for how to build other gates with NAND gate. By combining multiple NAND gates, you can recreate AND, OR and NOT gates. A single NAND gate can represent a NOT function when connected to both its inputs. Creating AND and OR functions requires specific arrangements of multiple NAND gates. You can move for building other gates with NOR gate. Similar to NAND, NOR gates can also be used build and OR and NOT gates. A NOR gate can function NOR gate can function as NOT gate when tied to both its inputs. Different combinations of NOR gates also for the construction of complex logical gates circuits. You can move for advantages of universal logic gates. Universal gates reduce the complexity of digital circuit design. They minimize the number of different gates types needed into a circuit. This leads to more efficient This leads to more efficient use of space and resources in circuit boards. You can see in the diagram logic gates how it separated. Basic logic gates, universal logic gates, other logic gates. In basic logic gates, you can see AND gate, NOT gate, OR gate. In universal logic gates, you can see NAND gate, NOR gate. In other logic gates, you can see XOR gate, XNOR gate. Move for applications of universal logic gates. Universal gates are widely used in microprocessors and other digital systems. They form the basic of programmable logic devices and FPGAs. Their versatility also engineers to create complex electronic devices with fewer components. Conclusion: Universal logic gates are essential for modern digital circuit design. Understanding their functions and applications is crucial for anyone in electronics. By mastering NAND and NOR gates, one can innovate and simplify electronic devices. Thank you for listening my PPT presentation.